So I will show you how to do question number 2 in self-exercise 1.8. Okay, I want you all to do the question again without looking at the solution. If you can't do, then you can refer to the working that I'm going to show. Okay, let's take a look at the question. Okay, in the diagram on the right are three identical 20-cent coins. Okay, you can see here there are three identical 20-cent coins which are touching each other. Okay, so identical 27 coins with the same radii and touching each other. If the blue colored region has an area of 12.842 millimeters square, this is the blue color region. You can see the blue color region inside. Okay, when the three coins are touching in between the three coins, there will be a small gap there. Then you are told that this blue color region, that region has an area of 12.842 millimeters square. Find the radius of the coin, find the radius of each coin in millimeters. So you are asked to find what is the radius. Okay, so if you look at the question carefully, what's happening is that you are given three coins of unknown radii, they are touching each other. Okay, when the three coins touch each other, there will be a small space in between. The area of that space is given. Okay, the area is given. You are asked to find what is the radius. Okay, let's take a look how to do this. Okay. Now, first of all, I want you to draw a sketch as usual. Draw a circle. Okay, draw a circle. Okay, each circle represents a coin. So you're going to draw three of these circles. So I resize this a bit, copy. So I got one coin over here and then one over here. So the three are touching like this. Okay. So the three coins are touching like this I showed. And you're asked to find what is the radius. And so what we do whenever we draw a circle, we put the center point first. So where are the center point? Probably the center point is somewhere here. And then the center of the circle also somewhere here. Then the center of the circle is here. Okay, and then draw a straight line connecting the center from here to here, one straight line, then another straight line here to here, another straight line here to here. Okay, so you got three straight lines connecting the circle. So we can put label A, B, C. You'll notice that in the diagram, no label is given. Okay, in the previous question, normally we have some labels coming in, but in this particular question, there are no labels given. Therefore, we put the label ourselves here. So we call this A, we call this B, we call this C. And then where the straight line AB crosses the coin or the circle, we label this point as P, this point as Q, this point as R. Okay, so you got 3 points, P, Q, and R. These are the points where the two coins touch each other. And the radius are not known, so we label the radius as R. So this is also R. So all the radius are R. So this is R, this is also R. Okay, the radii are all I. All they have the value of R, which is unknown that we are going to find in this question. Okay. Now we are asked to find what is the radius, but then you are given the area of the colored region. So here we write area of colored region is equal to, so if you look at the colored region, it's actually the shaded region. And now we can shade inside here. Okay, so you'll notice that the area of this region, okay, area of the shaded region is given by area of this triangle, okay, minus the area of each of these sectors. Okay, there are three sectors. So we write there area of color region equal to area of triangle ABC minus area of the area of the sectors. And there are three sectors here. You can see there are three sectors here. And there's one sector here, one sector here, another sector here. But the three sectors are identical. They are the same because all the three coins are the same coins, are similar coins. So what we do here, we just minus, we put here 3 times area of sector. So we can take any one of the sectors, and because the three sectors are same, so we put a APQ. Okay. So area of color region is equal to area of triangle ABC minus 3 times the area of sector APQ. Now, because sector APQ is same size as sector BRP and CQR. All the three sectors are the same area. So what we can do, this is where we are going to apply the equation we learned earlier, the formula for area of triangle ABC. So this is given by half AB sine C. So we have half times AB sine C. So to visualize this more clearly, I will draw another smaller triangle outside here, so you can see more clearly. Okay, so this is actually an equilateral triangle because all the three sides are same. So for example, if this is A, this is B, this is C, so the length, the distance from A to B will be R plus R. This will be 2R. Similarly, B to C is 2R, A to C also 2R. Okay, and because the three sides are of the same length, so this will be a equilateral triangle. Therefore, each angle will be 180 divided by 3 will give you 60 degrees. Okay, so area of triangle, remember half AB sine C. So half AB, A will be 2R, B also 2R times by sine C. So sine C will be sine of 60 degrees. Okay, so minus, I'll write at the bottom there. Okay, I think continue here. Minus 3 times area of sector is half R square theta. Okay, half R square will be half times R square times angle theta. So angle theta is 60 degree. I'm going to convert this to radian. 60 times 3.142 over 180 degree. Okay, so if you work it out, this part will give you, the front part will give you 1.732 R square. And then the back part will give you 1.571 R square. Okay, you can use your calculator to work out the value where you will get like this. So this is equal to 0.161 R square. Okay, but you are given the area of the color region. Now, if you look at the question, area of color region is already given. Okay, so area of color region is given. So that is 12.842. So it means 12.842, sorry, 12.842 is your area of color region. So that is equal to 0.161 R square. Okay, so from here you can work it out. R square will be equal to 12.842 divided by 0.161. Okay, so this will be equal to 79.76. Therefore, take the square root. Okay, it's easier to use just power of 0.5 in your calculator. So you'll get 8.931 millimeter. Okay, so that will be the radius, 8.931 millimeter. Okay, I hope you all can understand. Copy this first, copy inside your exercise book. And then later when you revise, all you have to do is don't look at the solution, do this one more time. Okay, understand the question first. So let's revise very quickly what we're doing here. You are given three coins, 20-cent coins, which are touching each other. So when the three coins, because they're circular in shape, when they touch, there's bound to be a gap in between. The area of the gap here, which is the shaded blue region, is given, but the radius is not given. So you're asked to find what is the value of R. So the easiest way to do this kind of question, which comes with pictures, is to draw a diagram. Okay, so when you draw a diagram and then you label all the different points and so on, you can easily understand and solve the problem. So you are given the area of the shaded region. So from here, the area of the shaded region will be given by area of triangle ABC minus the area of three sectors, APQ and BRP, and then CQR, these three sectors. But these three sectors, they have the same area. So we can just look at one sector multiplied by 3. So area of color region is given by area of triangle minus 3 times area of sector APQ. So area of triangle, remember the formula we learned earlier. This is something that you have in your head. Area of triangle, okay, is half AB. Area of triangle is half AB sine C. And then area of sector is equal to half R square theta. So we are using the same equation, same formula over and over again. So you'll be able to remember this very easily. Area of triangle, half AB sine C, and area of sector is half R square theta. Okay. So try this one more time. If you have any difficulty in understanding the working, please contact me by email. Okay. So I'll stop the recording here.